Sir, I'm Saurabh Upadhyay and today I'm here taking a new concept called limits. So first we'll take the motivation, why do we need limits, right? So consider I have one function like 7x by x. So straight away its value coming out to be 7. That means the value of function at anything it's 7, but the function itself is not defined at 0, right? So what is its value at 0? To answer that question, limit comes into power, right? So what we do into limits, we define the neighborhood at which the function is not defined. For example, here this function is not defined at x is equals to 0, right? So we'll take this point and around this point we create a neighborhood, right? And what we do, we try to approach x, right, from the left, from this side, and from the right, from this side, right? And we go very close to 0. We go very close to 0 and we try to approximate the value of function near that point. For that we have a system that is called neighborhood, right? So neighborhood means you consider some open interval around this point, that is 0 plus h, 0 minus h, where h is any positive small value. So this, like this, you need to define a neighborhood. Okay, so into limits what we do, if consider I have some function like this, so we'll take any point a and consider its value is not defined at this, right? So we take this point a and we approach towards a from the left and from the right to approximate the value of function at a, right? So this is what we do overall. Now to do this, we have few terminologies that we use, right? One of them is called RHL, another one is called LHL, that we need to understand, right? See, RHL means the value of function when you are approaching towards the given point from the right? Similarly, LHL, the value of function when you are approaching towards the value from the left, right? So when you are approaching from the right, you are calculating RHL, and when you are calculating approaching towards A from the left, you are writing like this, and your functional value is called left hand limit. Now we'll take few examples and we'll try to see when we will say our limit exists and when our limit is not existing, right? So for that, consider this example. Right? So this is your point. So if you approach towards this point A from the left and from the right, where h is greater than 0, your functional value is coming out to be, let's say, n, and here from the left m. So RHL will become, you're approaching towards the point A from the right, so RHL will become n, and LHL will become, you're approaching towards this point from the left, so LHL will become m, and the functional value itself is m, right? Similarly, if you have this kind of function, right, at A, you are saying like this, then if you are making any neighborhood, your RHL will become this, like this you need to go, and you need to reach n. LHL, this, like this you need to go, like this, and this is m, and your functional value is L. So your RHL is m, your LHL is m, and your functional value at A is L. One more example we can take to understand it in a better context. This is your function, this is the value at A, right? Let's say this is here. this is, let's say, m, this is, let's say, n. Okay, so if you are approaching towards A from the right, the value is coming like this, like n, so RHL is n. Similarly, if you are approaching towards A from the left, your value is again n, so LHL is also n, and functional value of A is this m. Certainly, all the three cases you can observe, and you can see that here LHL and RHL, they are different, but LHL and FA functional value, they are same. Here also you can see LHL and RHL and FA all are different, and here also you can say LHL and RHL, they are same, but the functional value is different. So what do we need to take from these all? So the point is, you can have LHL and RHL and FA of these three categories, right? When LHL becomes RHL anywhere, we say our limit exists, right? When LHL becomes RHL, we say our limit exists. For example, here we can say the limit exists, but here the limit does not exist. Here also, because LHL and RHL are different, the limit does not exist, right? So this is all we do into limits. Now we will take one example and we'll try to do that example, right? Before that, we need to know the working procedure. So the working procedure of calculating LHL is, RHL is, you are calculating functional value from the left, that is FA plus. So you will write it taking some positive value h, which is tending to 0, and you write your function like a plus h. Similarly, for LHL, you take the functional value from the left to A, and you are approaching towards A, and you write it limit h tends to 0, f of A minus h. Sir, what is this? H is equals to h tends to 0. See, if your domain is like this, you are making some interval like a plus h, a minus h. If you will decrease the value of h, you will be nearer to a. Means if h tending to 0, that means it's not 0, but it's going to get the value at 0. For example, it is like 0.1, 0.01, 0.001. It could be anyhow, very small. You need to make it very small, so that you can get the right kind of, you can read the right behavior of function very near to that point, right? So this is a system to reach very near to that particular value, right? Now we'll take one example. We'll try to understand that. F of x is equals to x square minus 4 upon x minus 2. So we have to calculate the limit as x is equals to 2. So see here, if you will put f is equals to 2, you are getting 4 minus 4 upon 2 minus 2, that is 0 by 0, which is not defined. So functional value definitely is not defined here, right? Functional value of f at x is equals to 2 is not defined. But we need to know the value, the behavior of the function near to. Likewise, I said, so we'll take the help of RHL and LHL very quickly. Okay, so RHL is FA plus, that is f limit h tends to 0, f of a plus h. A is here 0, 2, so we are putting 2 here. Okay, then we'll put this value at the place of this x, that is 2 plus h square minus 4 divided by 2 plus h minus 2. That means what? You're cancelling these 2 and 2, and you will open it, and you'll get 4 plus h square plus 4h minus 4 divided by h. So 4 and 4 get cancelled, 1 h is gonna cancel, so you are getting h plus 4. So limit is also here, h tends to 0, limit h tends to 0. So if you apply the limit, h will become 0 and your functional value from the right is coming as 4. Similarly, you can calculate LHL also. So limit h tends to 0, f of 2 minus h this time. That means limit h tends to 0, 2 minus h square minus 4 divided by 2 minus h minus 2. Meaning what? You can cancel this 2 and 2, and if you solve, you will get it to be 4 plus h square minus 2 4h minus 4 divided by minus h. So if you will cancel it, you will get minus 4 by h minus, sorry, you will cancel this h with this name and this one. So you will get h minus 4 divided by minus 1. So if you will take the limit at 0, h tends to 0, you will get minus 4 by 1, that is only 4. Minus 4 by minus 1. So this is how you calculate. So what we saw here, that LHL and RHL, both limits are coming to be same, right? So we say the limit of this function at x is equals to 2 exists, and we also saw here, we also approximated the value of this function near the value 2, right? And this is now how you need to calculate limit of a function, right? So we try to write this thing like, it's just to make you understand it quickly, but the formal definition looks like, if you have a function fx, right, and the function is not defined at some x naught, right, so you need to go near all the values, possibly very small, very near to x naught, and you need to see the nature of it. So we say, when x is tending to x naught, that means you are going very closer to x naught. Then if your function is going very closer to some limit L, it could be any definite number. So if you are reaching towards this x naught and your function is reaching towards, it's not taking the value L, it is just reaching. Sir, what is this reaching term? So consider my x is 2 and my L is 3, right? So you are reaching towards 2 means your functional value is 1.19, then 1.99, 1.99. The x is taking the values like this. It is more, the more you want, the more you can go. Similarly, this value, the function is going like 2.9, 2.99, 2.999, like this. Okay, so the more you go closer to this x naught, the more you will go closer to this L. So this is the idea and this is the concept. I hope you understand the concept. Thank you.